FST87 infinite series. So we've already done things that were infinite. What were they? Sequences. So do you remember an example from the first day of this unit? So we did sequences first. So really basic sequences, 1, 2, 3, 4, etc. And that's what they're going for. So that's a sequence. A series would be taking the 1 plus 2 plus 3 plus 4 for infinity. All right, and that's the example they used in the blue boxes on the bottom of page 542. Same thing. So, activity 1. We're going to start with this square. Now, we're going to be doing a picture that represents 1/2 plus 1/4 plus 1/8 plus, what's the next number? 1/16 plus 1/32 plus, you get the idea. So, we're going to shade it in. I'll use a different color because why not? So, I'm going to shade in 1/2 of this box. Then I'm going to shade in 1/4, which is just the remainder cut in half. Then I'm going to shade in 1/8, which is the remainder cut in half. Then I'm going to shade in 1/16, which is the remainder cut in half. If I keep going, will I shade in the whole square? Pause, think about it. All right, and so coming back, they want us to, 1, we drew the pictures. Step 2, write S2 as a single fraction. So S1 is the series. So on my first go around, how much was shaded? 1/2. S2, now that I've shaded 1, and now I'm shading 2, what total is being shaded? 3/4. What's the third one? Now that I've shaded 1/2, 1/4, and 1/8, what total is being shaded? It's going to be 7/8. Okay, and then if I did S4, so I'm adding 1/2, 1/4, 1/8, and 1/16, it's going to be 15/16. Can you find a pattern? Pause this and see if you can find a pattern that will find S5 without me actually having to add anything or shade anything. All right, coming back. So our patterns, if you notice, 1 and 2, 3 and 4, so they're 1 apart from each other. 7 and 8, 1 apart from each other. So whatever I get in the denominator, I can just subtract 1 and get the numerator. So that means my nth term of amount shaded at that point in time, I'm going to look at my denominators, and I'm just put the same thing in the numerator and denominator, put -1 on it. So 1 gets me 2, 2 got me 4, 3 gets me 8, 4 gets me 16. What else can, how can I do that? The base of 2 to the nth power. So 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. So this will be 2 to the n as well. This is my general pattern. And then they want to find S sub 10. So I could do 5, make that 31 out of 32. 10 would be 1,023 over 1,024. So that works through activity 1, so you can visually see your summations. But it's infinite, we could keep going forever. So when things go forever, you can either be convergent or divergent. I want you to read the book and see if you can figure out definitions for those two. I'm going to stop this video and then come back. That way you have to have definitions and you can compare with mine.